Swayam Prabha. Digital India. Educated India.
Welcome. So, in our last class, we were discussing about how to estimate a model using our statistical software Stata, right? And we learned how to estimate the model and then how to interpret the coefficients. We have also learned about the goodness of fit measure, and then we also discussed about our Anova table. So, that means when your objective is to analyze, is to explain the variation in your dependent variable with the help of the independent ones. So, how will you estimate the coefficients and interpret those coefficients and how to check the goodness of fit, right. Now, today what we will do, as we said yesterday in our last class, today we will discuss about hypothesis testing, which is very important. So, please be very sincere and careful. Sincerely you have to listen to this and understand, right, what is the hypothesis testing part. So, this is hypothesis testing that we are going to discuss, hypothesis testing. So, we will discuss this with the help of the same example. Let us say that this is our model yi equals to alpha plus beta xi plus ui. And when you estimate the model, your estimated model is yi hat equals to some 0.50 plus 0.75 xi. This is your estimated model, right. This is your estimated model. Now, from this model you can see that 0.75 is actually less than 1, but greater than 0, which we were expecting from the Keynesian consumption function hypothesis, right. Now, why hypothesis testing is required? As we said, we want to ensure that this value of beta hat here is 0.75. This value we are getting not by a chance factor, but we would like to ensure that there is a statistical mechanism that will ensure that even if you collect 100 samples from the same population, more than 90% of the cases you will get a beta hat value like this, right. So, that means it is not by a chance factor. In that context, how will you ensure the statistical significance? That means, so far what we got this 0.75, it is only mathematical significance. Mathematically, this 0.75 is obviously different from 0, but how to check the statistical significance, and that is the context where hypothesis testing is actually required. So, what is a hypothesis? First of all, what is a hypothesis? Okay. So, a hypothesis is basically a guess. A hypothesis is actually a guess about the true population parameter. Okay. Hypothesis is actually a guess about the true population parameter. So, in this context, what is the true population parameter? Alpha and beta. let us say beta here, about the true population parameter beta. Okay. So, what is our guess? We are guessing that beta hat is actually greater than 0. Okay. That means income has significant impact on consumption. That is the guess we are making about the true population parameter. Okay. Guess about the unknown true population parameter. Since it is unknown, we are making this guess, right. Now, there are two types of hypothesis. One is called null hypothesis, denoted by H naught, okay. What is null hypothesis? Now, null hypothesis, the definition says that a hypothesis that nullifies our claim is called null hypothesis. A hypothesis that nullifies our claim is called null hypothesis. So, from the name itself you are getting this. Okay. Null hypothesis is a hypothesis that nullifies our claim. Now, in this context, what is our claim? Our claim is that income has significant impact on consumption. That means, if you nullify, what would be the hypothesis? Income does not have any significant impact on consumption. Then how will you make your null hypothesis? In terms of this notation, you will say that beta equals to 0. That is our null hypothesis. Okay. So, your claim is beta greater than 0. That means, income has significant impact on consumption, and then you nullify. And you will get your null hypothesis, which says H naught is beta equals to 0. This is one way of understanding null hypothesis or defining null hypothesis. There is another way of defining null hypothesis, which says that a hypothesis that assumes no difference between sample statistic and the population parameter. That means, how will you define your null? Beta hat equals to beta. There is no difference. Now, this way of defining null hypothesis is little difficult to understand. So, I will make you understand the second definition of null hypothesis in a later part of our discussion. For the timing, you just understand a null hypothesis is a hypothesis which nullifies our claim. Simple. You try to identify your claim, that my claim is income has significant impact on consumption, then you nullify. Okay? If you nullify, then what will happen? You will say that income does not have any impact on consumption. That means beta equals to 0. If beta equals to 0, then x does not have any impact on y. Very simple. And then the other type of hypothesis is called alternative hypothesis. So, beta second type of hypothesis is alternative hypothesis. Alternative hypothesis. So, when your null is beta equals to 0, so alternative is denoted as HA, which says beta not equals to 0. So, that means opposite or alternative of null hypothesis opposite or alternative of null hypothesis is called alternative hypothesis. All right. This is what is hypothesis. Now, in hypothesis testing, we need to understand certain concepts. Okay? We need to understand certain concepts that will help us understanding hypothesis testing procedure. First of all, the concept that we would like to discuss is test statistic. Test statistic. Okay, test statistic. What is the definition? A statistic that helps deciding whether to reject or do not reject the null hypothesis. A statistic that helps deciding whether to reject or do not reject the null hypothesis. Now, why we are rejecting or do not rejecting the null? Because you see, when I say H naught beta equals to 0, if you reject the null hypothesis, then only you can establish your claim, isn't it? So, that is why our objective here in this hypothesis testing is either to reject or do not reject the null hypothesis. If we can reject the null hypothesis, then we can establish our claim. When beta equals to 0 is rejected, that means we are saying that income has impact on consumption. If we are not able to reject our null hypothesis, then we will say that income does not have any impact on consumption. And how are you going to decide that? With the help of test statistic. So, the value of the test statistic will help us deciding either to reject or do not reject the null. For example, there are several examples are there like T statistic, then F statistic, chi-square statistic, which you might have studied in your statistics course. Here, when our objective is to check the significance of a particular variable, we will use the T statistic. And how the T statistic is defined? T statistic is defined in this way. The definition is estimated value of population parameter minus the parameter divided by standard error of the estimate. That means, in terms of notation, estimated value of the population parameter is beta hat minus what the parameter, that means beta, divided by standard error of the estimate, that means standard error of beta hat. Standard error of beta hat minus beta divided by standard error of beta hat. This is how we define our t statistic. Now, from this definition of the test statistic, we can understand the alternative definition of null hypothesis also. What is the null hypothesis? We say the alternative definition says that there is no difference between the sample statistic and the population parameter. Now, here how we are constructing the numerator is estimated value of the population parameter, which is nothing but the sample statistic beta hat minus the parameter, population parameter beta. So, since your null is saying that there is no difference, and here our numerator is constructed based on the difference between beta hat and beta, that means higher the difference between these two, larger would be the value of t, and more information we would be able to gather to say that yes, actually there is a difference between, significant difference between population parameter and the sample statistic. Now, the population parameter is unknown, that is why here we will say that instead of beta we will say that hypothesized value of beta under H naught. So, the original definition is beta hat minus beta, but then beta is unknown population parameter. Unless you put some value for beta, you cannot get a value for t statistic. That is why in place of beta, what we will do, hypothesized value of beta under the null. And what is the hypothesized value of beta under the null? That is 0. That is why t statistic is defined as simply beta hat minus 0 divided by standard error of beta hat, or simply beta hat by standard error of beta hat, and this follows t distribution with n minus 2 degrees of freedom. Okay. This follows a t distribution with n minus 2 degrees of freedom. Now, how does this t distribution look like? T distribution looks like a normal distribution. Why this is so? Because we assume ui follows a normal distribution, and when ui follows a normal distribution, let us say 0 mean and sigma square variance, that ensures that beta hat also follows a normal distribution. And when beta hat follows a normal distribution, obviously beta hat by standard error of beta hat will also follows a distribution which is similar to normal, but with a little flatter tail, because we are dividing that with standard error of beta hat. Is this clear? So, ui follows a normal distribution, that is why beta is also following a normal distribution. So, when we divide the beta by standard error of beta hat, the resultant distribution, which is actually t, becomes little flatter than the normal distribution, but it is a normal distribution which has the properties of the normal distribution, basically symmetric around this mean value. This is symmetric around mean value. Okay. This is how the test statistic is defined. The next concept that we need to know is critical region. critical region. How we define this? A set of values of the test statistic, a set of values of the test statistic for which null hypothesis get rejected. Now, I will explain this critical region using the diagram. This is your T distribution, and critical region, that means there are two areas in the left side as well as in the right side of the distribution. So, in this diagram what we are doing, this is the density, and here we are putting several values of the test statistic T. Okay. And the critical region lies in the two tails of the distribution. For the timing, let us say that the size of this critical region is 5%, that means here it is 2.5%, here also it is 2.5%. Okay. This is basically called alpha by 2, and this is also alpha by 2. So, that means this region is basically 1 minus alpha. So, a set of values of T for which null hypothesis gets rejected is called critical region, and these two are actually the critical region. This is the critical region. This is also critical region. Okay, critical region. That means what I am saying, that now why the critical region lies in both the sides of the distribution? Because your null hypothesis says, your null hypothesis is beta equals to 0, and alternative hypothesis is beta actually not equals to 0. Since alternative is beta not equals to 0, that is why it can be either on the left side or on the right side of the distribution. That is why when your alternative hypothesis is a composite one, like not equals to 0, your critical regions will lie on both sides of this. And since the T distribution is symmetric, the area is actually the same when you are considering in the right side as well as in the left side. So, that means it is alpha by 2, this is also alpha by 2. This alpha is actually little different from the alpha what we have used in our econometric model. This is not the intercept, this is different. That is why you may change your model like yi equals to beta 0 plus beta 1 x1 I, beta 1 xi plus ui. So, now instead of alpha I have used the beta 0. So, this alpha is actually different. Okay. This alpha is different. Now, how will you decide whether to use reject or not reject? That means you can calculate your test statistic immediately after estimating your model standard error of beta hat. So, that will give you, this is called calculated value of T, calculated value of T. Okay. Now, look at the definition of t, it is t equals to beta hat divided by standard error of beta hat, and that is why you are going to get a distribution. Now, what will happen if our sample is not random? If our sample is not random, that means what will happen? What happens for a non-random sample? What happens for a non-random sample? Now, if you get a non-random sample from the population, you can get only one such non-random sample. And if you do not get multiple samples from the population, if there is no randomness in the sampling part, then what will happen? You will get only your beta hat. So, the standard error of beta hat, what is the standard error of beta hat? Standard error of beta hat is basically the standard deviation of the probability distribution of beta hat. So, if I define standard error of beta hat, it is basically standard deviation of the probability distribution of beta hat. So, in a non-random sample, since there is only one such sample you can collect, you will get only one beta hat. So, distribution of beta hat is not a possibility when you are going for non-random sampling. That means you can estimate your beta hat with that non-random sampling, but you cannot go for hypothesis testing, because hypothesis testing requires test statistic to be computed, which again requires standard error of beta hat to be computed, which is nothing but the standard deviation of the probability distribution of beta hat, which we can get only when the sample is random. But that does not mean that I will be collecting actually so many samples from the given population, but that randomness should be there, so that by the assumption, distributional assumption of the error term, we can ensure that a distribution is possible to get for the estimated parameter beta hat, and standard error of beta hat is also possible to get, right, is also a possible to get, and that is why we said that once you get the beta hat divided by beta hat is standard error of beta hat, you will get the t statistic, which is called calculated value of the t statistic. Okay, calculated value of the t statistic. Now, if your calculated value of the t statistic so defined is greater, calculated value of t, let us say this is called t cal, is actually greater than tabulated value of t. Tabulated value of t at a specific level of significance and degrees of freedom, then we will say that reject your null. Okay. Now, this calculated value can be either positive or negative depending on the sign of your beta hat, but our decision making rule is always same, which is calculated value of the t is the tabulated value of t at a specific level of significance and degrees of freedom. That is why I will say that this is t modulus is greater than tabulated t. Now, this tabulated value of t, if you go to your statistics book, you will get a table for t. That means that table will tell you at a specific level of significance. What is level of significance? I will explain. For the timing, you just keep in mind that at a specific level of significance and degrees of freedom, that mod value of t, which is calculated by beta in this formula, should be greater than the tabulated. If you go to the table, t table, if you specify your level of significance and degrees of freedom, you will get a value. For example, here let us say this tabulated value is 2.94 when your alpha is 5% and your tabulated value is, let us say, 3.75. Let us say this is 3.75 and this is 2.94 at alpha equals to 5%. That means I am saying the size of the critical region is 5%. That is why I am saying that 2.95, this is 3.75 and this is 2.94. Since the 3.75 is greater than 2.94, that means you are actually entering into this critical region, either this side or this side depending on the sign, but your decision making rule would be same. Now, the question is, how will you get this value 2.94? Okay, how do you generate the calculated tabulated value of t? How do the statisticians they prepared this type of table? The idea is very simple. They have actually applied the concept of definite integral. Here what we are happening, if you recall, in our definite integral, generally we used to get two limits and then the function fx dx, and we used to get a specific value, right, specific value. If you know fx, if you know a and b, you will get a value. Now, following the area property of the definite integral, what we are doing here is the reverse integration. That means you know that the range of this is minus infinity to plus infinity. So, I am specifying a problem like this, minus infinity to, let us say this is b, and this fx or let us say ft dt equals to 5%, that means 0.05. So, what I have to determine here? What is b? So, you know the lower limit of the integral, the upper limit you need to decide b, so that this area becomes 5% or 0.05. That is the idea is followed by the statistician, and you get several values of t the moment you specify the area. Instead of 5%, you can make it 10%, you can make it 1%, you can make it 4%, and immediately you will get a value if you do the procedure of reverse integration. This is the idea. Okay, this is the idea how the statistician they have prepared the table, and the decision making rule says that your calculated value of the t, which is defined by beta hat divided by standard order of beta hat, then you have to compare that with the tabulated value, and immediately you will see whether that is greater than the tabulated one or not.